Okay. I hope you guys had no questions today.
So the telecom.
So what I'm going to do is first look at section 10.3. We only began 10.3, but we have a lot to go over, and then I'll give you the quiz toward the end. So we are looking at section 10.3. I thought you would be excited to take the quiz, right? You can earn extra points for the exam. I might. Okay, so I'll let you know later. Okay, so here's a 10.3, and this is on what? Polar coordinates. And so let's recall what we did, how we defined it. First of all, let's say that I have a real number line. The arrow indicates the positive side of the real number line. And so first of all, imagine that you have a x-axis, and the x-axis is the yellow number line. So yellow line, that's a copy of the number line, and let's say that the origin is right here. So that's the number 0. Number 0 is represented by that point. Now the black arrow, that's another copy of the real number line, and I'm going to call that the polar axis, right? So if I have a point P somewhere, let's say right here, the question would be, what are the polar coordinates of this point? And so the way what we are going to do is we are going to rotate the polar axis until we intersect the point P. So one way to rotate the polar axis is that we could go through the origin. I guess I'm going to have to change my point P. So I am going to change my point P. So let's say the point P is here. And what are the polar coordinates? Well, if this angle here, is theta, so we rotated the polar axis through an angle theta, then the polar coordinates of P are given by r and theta, right? So what is r? R is, remember, the polar axis is a copy of the number line. So the arrow indicates the positive side of the number line, right? So the number, the R is basically the real number represented by that point P, right? On the number line, P represents a number, and that number is R. Another interpretation for R is what? Another interpretation for R is that R is the distance of P from the number 0, right? That's another. I usually call that the radius. Okay. So it's the radius of P, comma, the angle theta. However, there are many other ways we can rotate the polar axis and still intersect the point P, right? So what are the other ways? Well, you can note that if I rotate my polar axis, so I'm going to go round and round and round as many times as you want, and then, so let's say this angle is theta plus a multiple of 2 pi, which is 2n pi. So how many times did I rotate? I rotated n times, right? N times, and then I added theta, so I came back to the same, so that my polar axis is positioned at the same place as theta, right? Right. So the position of the polar axis for theta and theta plus 2n pi are the same. So another way of representing the point P would be the same value r, but theta now is theta plus 2n pi, right? Everybody's okay? What would be another way? Another way is that I could also rotate. I can use, what is this color? I don't know. Okay, so here's another way I can rotate, right? I can rotate like this. Is that magenta or something? Anyone knows? What's that? All right. So this is what is this angle, by the way?
That's
Theta plus pi. So clearly, I can also represent P with well, not R, right? This time, what is the positive side of the polar axis? The positive side of the polar axis is given by this arrow, right? The arrow in magenta is telling you positive side of the polar axis. So this side here, the side from here to here, right? This side is the negative side of the number line. So now R is negative, right? So assuming that the symbol R is positive, then I should write negative R here, and then this would be theta plus pi, right? Theta plus pi. However, notice that if I add now any multiple of 2 pi, right? If I add any multiple of 2 pi, I would come to the same position, right, as theta plus pi. The position of the polar axis, the direction of polar axis and the position would be the same as theta plus pi, as for theta plus pi, if I add 2 and pi. All right, so there are many possibilities. So basically, all I need is these two, right? These two describes all the possibilities, okay? These two describes all the possibilities. Now, in the exam, if you just give me the polar representation with positive R, I would be happy, okay? And I'll give you the full points. But you do have to give me general theta, Okay, so whatever theta you find, basically you add what? 2 and pi. So what is n here? What is n here? N is any integer, right? Any integer. So it could be any positive or negative integer here. All right. So next, how did I show you the relationship between rectangular coordinates and polar? Okay. So what did we do there? We said, well, let's make a vertical line from the point P to the x-axis. So let's call this side to be x, and let's call this side to be y, right? Then, can someone tell me what is r squared? Because by using the Pythagorean theorem, right? So this would be x squared plus y squared. And then what can I say about x? What was x? So let's use trigonometry, okay? So what is x equals to? You realize that x divided by the hypotenuse, right? Adjacent over the hypotenuse would be x over r, would be cosine theta, right? So what would be x? R times cosine theta. Same way, notice that y is the opposite, so y divided by the hypotenuse would be sine theta, right? So y over r is sine theta, so y would be r sine theta. Y would be r sine theta. Everybody realizes that? And then I could also say that tangent of theta is y divided by x, opposite over the adjacent. Okay, so there isn't any r. So these are the conversion formulas from one coordinate system to the other. So let's have I done any examples with this? So let's do a couple of examples here. Let's say the question is convert the point -3 comma pi over 6 from polar coordinates to rectangular coordinates. Do you guys know what's the other name for rectangular coordinates? Cartesian coordinates, yes. So you might see that word in the textbook or some other places. Okay, so how do I do this? Well, I need to know the rectangular coordinates, right? So what are the rectangular coordinates? X and y, right? So what's the relationship between the Cartesian coordinate and the polar? This is my r, right? And this is my theta, right? What's the formula for x? R cosine theta. What is r? -3. What is cosine? Pi over 6. And cosine pi over 6 is what? It's √3 over 2, right? Okay. What is y? Would be r sine theta, right? Which is going to be -r sine pi over 6, which would be -3 times a half. By the way, after last Friday, when the students did remind me of the quiz, some of you might know one of our stat professors here, Larry Robinson. One of you know him, and I told him about it, and he was like, "Oh yeah, students pulled that pull that on me all the time. Okay, so apparently he forgets about quizzes pretty often. All right. All right, so here's okay, so we found, so this is very easy, right? Converting from polar to rectangular is very easy. You just apply the formula. As long as you know the standard values of sine and cosine, you'll be okay. Now, the other way around, though, is not so easy. So let's say I want to convert the point. Let's take the point. Let's take the point -2 and 2 root of 3. Let's say I have this point, and I want to convert this point from rectangular boy, it's going to be this cell phone ring will be recorded now, from rectangular coordinates to polar coordinates. Alright, so what should I do? What would be the first thing I compute? Okay, very good. So I should say r squared is x squared plus y squared. So here, this, what is x? This is x and this is y, right? So what do I have? -2 squared plus 2 root of 3 squared. And what is that equal to? What's that? What is that equal to? 16. So r is what? It could be plus or minus 4. Okay, now I need to know, by looking at the point, can you tell me which quadrant does it lie in? It's in the second quadrant, right? Because x is negative, y is positive. Everybody is okay with that? It's in the second quadrant. The point lies in the second quadrant. Now, in the case r is positive, okay, in the case r is positive, what angle can I pick? What should be theta? Well, let's see. X is what then? We know that x is r cosine theta, right? X is r cosine theta. And we know that y is r sine theta. So in this case, what is x? -2. R is, I'm taking r to be positive 4. Cosine theta. Y is, y, not y. It's 2 root 3 is 4 sine of theta. And so we get cosine theta. Cosine theta is a -½ and sine theta is √3/2, right? So can someone tell me, give me an angle theta in the second quadrant, right? Can you give me the smallest positive angle theta in the second quadrant for which sine theta is -½ cosine theta is √3/2? Yeah. Remember last time when I showed you that picture? Let me see. It wasn't. Yes. I'm trying to see where I wrote that. Oh, I deleted those numbers. So okay. So here's first of all, can you give me a point where cosine theta is half? Well, cosine theta is half right here, right? Right here, cosine theta is half, and sine theta is √3/2. So if I want to know where cosine theta would be negative half, all I have to do is go directly across, right? So let's see. Yeah, if I go directly across, I'd be getting here. Is that making sense? So the angle would be 2 pi over 3. So so I know that theta would be 2 pi over 3. Everybody's okay with that? Now, of course, once I find the value of theta, what would be the general values of theta? Well, I simply add a multiple of 2 pi. If I add a multiple of 2 pi, I get all the possible values of theta. Everybody's okay? So what am I getting in this case then? Then the polar coordinates are becoming what? 4 and 2 pi over 3 plus 2n pi. Okay? Now in the case r is negative 4, in the case r is negative 4, what would be the polar representation? We should know this. What would be the polar representation? One thing I could do, right? One thing I could do, I can replace r by negative 4 now, right? Negative 4, and go over the same calculations if I want to, but I don't really have to do it. Right? Why is that? Why is that? Yeah, all you have to do, remember that if you want to get negative r, right, all I had to do is add pi to theta. So, yes, so in this case, if I make it negative 4, if I make r to be negative 4, all I have to do is add a pi to the value of theta that I have. Okay, so if I add pi to it, what do I get? 5 pi over 3, and then I add 2n pi. Is that making sense? So actually once you find polar representation with positive r, the polar representation for negative r is actually easy, right? You just have to add pi and you're done. So that's why I sort of said, if you give me the answer for positive r, I'm happy, because really for negative r there is nothing to do, right? Is that making sense? Okay, so and you can see that converting from rectangular to polar is the harder problem, right? The other one was very easy. So which one do you think I'm going to ask you in the exam? Was that? Yeah, I'm going to ask both of them. Okay, so here's okay, we have gone over that, and sometimes you want to, sometimes if I give you I might give you a rectangular equation, meaning that you have an equation with rectangular coordinates x and y, and you have to convert it to polar into an equation involving r and theta. So here's a type of problem where you convert equations from one system to the other. So let's say you want to convert the equation x squared plus 2x plus y squared equals to 3 from rectangular coordinates to polar coordinates. Okay, so here's this type of skills will be needed in Calc 3. Okay, so here's x squared plus 2x plus y squared equals to 3, and my job is to convert to r and theta, right? So what should I do? What should I do? Well, I'm going to do the harder part. 3 will stay as 3, right? Okay. So what should I do on the left? Was that?
You said x equal to r cosine theta,
Mm-hmm.
and y equal to r sine theta.
Right. But in this case, I can save a little bit, right? I mean, I can do a little bit less work here because these two combines to what? R squared, right? Remember, x squared plus y squared is r squared. So I can combine these two into r squared, and then 2x that I have, I can just replace x by what? X, remember, was r cosine theta, right? X was r cosine theta, and I'm done. Okay? So now the question is the other way around. Let's say I want to convert I'm going to use the word rectangular equation versus polar equation, but that's not a standard jargon. Okay, so but I'm gonna use it. So convert the rectangular equation. Oh no, not rectangular. I'm sorry. Whoops. Yeah. Okay, convert the polar equation. And the equation I have in mind is R is 2 cosine theta. So convert the polar equation to rectangular equation. Okay, how do I do this? R is 2 cosine theta. Well, in this case, you can realize that if I multiply both sides by r, I'm going to get r squared is 2r cosine theta. And then I know r squared is what? X squared plus y squared. And I know that r cosine theta is x. So you're done with this question here. You convert it into rectangular, but sometimes you might be asked, do you recognize the graph of this equation? Okay, what's the graph of this equation? Well, if you look at this equation in rectangular, can you recognize what that is? Note that what I have now is x squared minus 2x plus y squared equals to 0. I want to complete the square for x. So what should I do? I should be taking the half of the coefficient of x and then square it, which is 1. So I am going to add 1 on both sides. So it doesn't change my equation, right, if I add 1. And then x squared minus 2x plus 1 factors into what? X minus 1, so x minus 1 squared. And the y squared that I have, I'm going to intentionally write it as y minus 0 squared. And the 1 that I have, I'm going to write it as 1 squared. So this is the equation of what? What's the general equation of a circle? The general equation of a circle is x minus h squared plus y minus k squared equals to r squared, right? So what is the radius in our case? This is a circle where the radius would be 1. And what's the center? The center is 1, 0. Everybody's okay with that. The center is 1, 0. So basically then, let's draw the circle. Basically then, what I have is a circle of radius, what was that, radius 1, centered at 1, 0. So the center that I have here, that's at 1, 0, okay? So my x-axis, whoa. Let me make my x-axis here for a second. So that would be my x-axis, roughly. This would be the y-axis, roughly. Right, and the center is at 1, 0. So that's 1, 0. Right. The radius is 1. So this number here is what? 2. Right. So that's the graph of this. That's the graph of this equation. Everybody's okay? Now, can someone guess? Instead of having cosine theta here, so here instead of having cosine theta, if I have sine theta, can you guess what would be the graph? From knowing that the graph of this one is this, yeah, it'll be a circle of radius 1 centered at 0, 1. Very good. So you're going to have the circle set on the y-axis instead of the x-axis. Everybody is okay with what I said so far. Okay, so I think I'm going to stop here just because if I start another example, I will forget about the quiz.
Can you show us more?
Okay.
Can you show us one more? Come on, you turn to your picture.